All right then. So, hi everyone. I'm Chris Saxon. I'm part of Stephen Feuerstein's Oracle Developer Advocate team. It's my job to help you get the best out of Oracle database and hopefully have a little bit of fun whilst doing so. So with that in mind, I'm excited to be here for today's SQL Office Hours session. So this is your chance to ask us your questions about SQL, anything you want to know about how to do it better. So we've had a few questions coming in advance, so we'll look at those. Hopefully they won't take too long, so we'll have plenty of chance at the end for you to ask whatever you want. As always, put your questions in chat and I'll keep half an eye on it and as we go along. So let's just bring up these slides. Okay. Whoop. Question straight away from Charlie. Okay, so Charlie, we'll come back to that later on. And like I say, I've got a couple of things to cover off first, and then we'll come back to your question. So keep that in mind and remind me later if I haven't covered it, Charlie. All right then, so let's begin. So to start off with, we had a slightly weird question come in. So someone was doing an insert statement that looked a bit like this. And they're saying, trying to insert into a table, selecting some values from dual where not exists values from the table. And it's like, well, why does this add duplicates? So this is a bit of a weird statement to start with. There's lots of subqueries and stuff going on. So the short answer is, well, I don't really know, to be honest. I can't understand really what's you're trying to achieve with this statement. So if the person asks these questions on the chat now, please let us know. Please give us more information and background about what you're trying to achieve. But there are some observations I had about why this might be leading to duplicates. So to start off with, we can see we're selecting some bind variables, C1 and C2. But we're doing our not exists query against a hard-coded list of values. So we're saying we're passing some bind and saying, but only if C2 is not in the values or in the values 1 or 2. So, what happens if we pass 0 or 3 or 4 or something like that? That not existence check is going to fail. And we're going to stick that value in. So that's the first kind of weird, suspicious thing that's going on there. The other strange thing is we've got this scalar subquery here, so we're selecting, but that is from a different table than either the one we're inserting to or the one we're doing the not existence check against, even though it has a very similar, where clause where C2 equals 1 or 2. So again, there's something weird and strange going on here. So I don't really understand what the thing is. So if you're on the call, please give us more details. But the other reason for kind of bringing this up is just to highlight, it's really important that we get a full explanation of your problem. So create tables, inserts, and the output you expect based on what you're trying to do. Otherwise, we're doing a lot of guesswork here and we don't really understand the situation. So please let us know if you've got more comments on that, if you're on there. If any of you watching have got any questions or comments on this statement, let us know in the chat. If not, we will move on to the next thing, which is kind of an interesting question. Okay, so I'm not seeing anything come in. Don't worry, if you're furiously typing away, it's all right. I am keeping half an eye, so we can come back to it. So the next question that came in was an interesting one relating to interval partitions. And so what they wanted to do was define a naming patterns for the generation of interval partitions. So this is a good question, actually. Before I answer it, let's just give a bit of background into partitioning generally and interval partitions in particular, just so you're all on the same page and understand what's going on. So, excuse me. So partitioning, this is the process where you take one table and logically split it up into several smaller tables. The advantage of doing this is then you can run queries which access just one partition, so a smaller subset of the data, hopefully making your queries a bit faster. This is also really useful for things like data lifecycle management. So quite often companies have legal or internal business requirements to archive off data once it's older than 2 years, 7 years, or whatever it is. Partitioning by date makes it really easy to kind of drop off old partitions. So you can say, we don't need this data anymore. Either we've archived, copied it to long-term storage, or we just want to get rid of it completely. some liability associated with having this. So we'll just drop it. We'll get rid of that information. So partitioning your table by date makes this really easy. You can say, what's that oldest partition? Let's just get rid of it. So date partitioning is really common use for this kind of life cycle type management, but it can be a bit tricky to work with, or traditionally it has some problems associated with it. So let's say we've got time going on and we're creating monthly partitions. So on the first of each month, data goes into a new partition. So that means we need a process which every month is creating a new partition. So if we're back in October, we need partition for values there. November, we need the partition for the values before the 1st of December. So the current month, we need the values before the 1st of January. So this is great, but quite often with these kind of systems, it's been my experience that people then forget to create partitions for whatever reason. So it comes to the 1st of January and oops, there's no partition there. And of course, it's New Year's Eve. Half the people, nobody wants to answer their phone to deal with on-call sport tickets, and their whole application falls over in a heap. So this isn't great. We've got a situation where we need to create new partitions every single month to stop us falling into this black hole where you get lovely error errors because values can't go into a particular partition. There is no matching partition for what we're trying to do. So classically, there were a couple of solutions to it, which worked, but both had their own drawbacks. The first was you just kind of pre-created a whole stack of partitions. So, once a year, for example, you'd create the next 12 months worth of partitions, and then you'd have a scheduled task, or ideally a scheduled database job, which just generated those partitions for you. So nice and easy, but of course, it's one of those things, because it happens infrequently and it's a background task, easily forgotten about. A year is just about long enough for people to completely forget all those routine tasks they were supposed to do last year, particularly if there's any staff changes. The person who traditionally did this moved on to a different job for some reason. So quite often you find holes appear, or gaps appear, where people were supposed to create these partitions and now they're not. Or you've got the job, you've got the scheduled job which does it for you, but it fails for some reason and there's not sufficient alerting and monitoring to tell you that the whole thing's fallen over in a big heap. So pre-creating is a great idea, but it has some drawbacks. So then there's another technique. You can say, well, rather than having a fixed upper bound for the last partition, what you can do is set the upper bound to max value. So that is just whatever values you insert. Anything that goes beyond the current specified value will go in this max value partition. So this is just a catch-all bucket, which everything goes in. So this is great. Your application is no longer going to throw some errors because it can't insert stuff into a particular partition. Partition always exists. We're fine from that point of view. But you still need a maintenance task to split this max value partition out into the monthly ones as time goes on. And again, it's another one of those tasks which is easily forgotten about, overlooked in time, and so on. So you can easily end up with a situation with a single or a really huge max value partition which spans months and months and months because people either forgot to do the routine task, or the job that you scheduled to do it broke for some reason, nobody noticed. So they're little niggles, but they're just niggles. So they're just ongoing little tasks that you have to do to keep these date partitions actually working. So in 11G, we introduced interval partitioning. So you do that like this. You create the partition, say partition by range, and then you specify an interval. And here we're saying interval 1 month. So for each new month that elapses, we will create a new partition. So you can, as soon as a new value comes in, which is above whatever the current high value for the partition is, it will create the partition for you automatically. So you don't have to do anything. All these problems with trying to remember to do it or possible failures have gone away. We handle it all automatically for you, nice and easy. So this is help things be nice and smooth and easy. So we've got this, we're creating new partitions. Now do note, when you're doing this, you do have to have an initial partition. So this has to be the baseline, and things values before that will go in that initial partition, and then we'll create the monthly partitions then after that. Okay, so any questions or comments on this before we move on? Okay, I see something from Pojin. What's the recommended indexing strategy or for table archival and temporal validity, for example? Assume. Okay, so Pojin, I think we'll come back to your question on indexing a bit later. So we'll go through these things on interval partitions and come back to that to round this off when we've finished up. Okay? Okay, cool. I'm not seeing any other questions or comments come in at the moment, so let's motor on. So we've created our table and we'll stick a whole bunch of data in it. So we're sticking 100 rows in it, and there's a row per day. So what's that? 3, 4 and a bit months or something like that. So when we do that, we then will create those partitions for you. So we can see when we query tab partitions, we got P0, our initial, and then we got our 4 new partitions. Now notice these have these lovely sys underscore names. I was like, this is a bit cryptic, right? So how do you know which partition each row goes in, or the name of the partition? Because if you want to do partition maintenance operations, such as drop it, merge it, whatever, and so on, you need to know that partition name. And if it's a sys-generated name, it's like, oh, well, it's a bit tricky, right? A bit tricky to figure out what it is. Now you might go, well, why don't we use the high value from user tab partitions? And it's like, looks great, doesn't it? It's got the date, that's the upper limit. Problem is, it's a long, right? The long deprecated data type in Oracle database, which is still clogging up the data dictionary, unfortunately. So this is a bit tricky to work with. You can't run SQL queries directly against longs to try and figure out what value it is. So we got these cryptic names for the partitions, and we can't really use the high value very easily. So we're kind of a bit stuck. And I think this is where the request comes in. Is there a way to name these? Can we have a way to name these partitions according to some kind of regular expression or something like that? So before get back to that, let's just keep looking at this long. So let's say we want to find, we want to convert this long into a real value we can actually use. Fortunately, there is a really handy trick. What you can do is if you've got a long, and you can do an execute immediate, selecting it from dual, and because it's got the to date, it will do the conversion for you. So we can do an execute immediate like this. So if we simplify it, we've got our conversion there. If you get the values out of star tab partitions, whichever one it is you're using, select that high value from dual into a date variable, and then you can use that as your execute immediate and to char it, to rename it. So like P, year, month, day, whatever scheme that makes sense and is logical to you, so you can identify and know what these partitions mean. So you can do this kind of after the fact to figure out what they are. So the question that came in is, well, can't we do this automatically? Can't the database figure this out for us? Unfortunately, there is not any plans to do this, or at least none that I'm aware of. So at this point, I'd say, if this is something you'd like to see, or in fact, if there's anything you'd like to see in Oracle database, I really recommend you go to the Oracle Database Ideas Forum. So what this is it's part of the Groundbreakers Forum. So it used to be the OTN, Oracle Technology Network, we're now called the Groundbreakers Hub. And what it allows you to do is submit suggestions for things that you would like to see in Oracle database. And there's a lot of suggestions in there. And the PM team do review this and see what has actually come up. So I'll put the link in the chat if you just give me a second to pull it up. I meant to do database ideas. There we go. So if you take a look at that, you can see a whole bunch of things that people have suggested. So you can see other people's suggestions, comment on them, vote them up or down, depending on whether you think that's relevant or useful. So as I said, we do review this and we take it in mind when deciding what to implement next. Now, popular suggestions, just because something's popular, there's no guarantee that we're going to do it. It also depends on, what we want to do with the product, how feasible it is. There's some really popular suggestions which are tricky for us to implement, so are unlikely to happen soon. But certainly something's easy to do and has a lot of support, there's a good chance we'll get it done. So do check that out, take a look, see if there's things that you would like to suggest or add, or comment and vote up on existing solutions. So check that out. So the person asking this about these interval partitions is a great place to go to submit this as an idea. Okay, any questions or comments on that? All right then. Okay, so having covered that, we're kind of stuck with these sys-named partitions for now, or at least until you go through the process of renaming them. Now, some of you might want to find ways to actually identify the sys name for a particular partition. What is it? How, rather than looking at the data dictionary. So there's, or other than, trying to parse out those long values and see what they are. So there's a couple of techniques you can use. So let's look at them. One is, how do you get the last partition? How do you get the name of the last partition for a table? Now, for range partitions, so these are sorted in range value, so date value for date range partitions, and the last partition will be the one that has the highest date. So how do you get which one that is and the name of it? Well, you can do it with a neat little query that looks a little bit like this. So this is a bit weird, and it uses the the dense rank last or first function. It's slightly confusingly named, if you ask me. You look at we got this keep syntax, which is some ways a bit like over for analytic functions, but we has keep here, but that's not what it's called in the docs. We call it first and last. Don't ask me why. Anyway, so what's really going on here? Well, we're sorting the values by partition position. So each partition has a numeric value corresponding to where it sits in the sequence. And the last date partition will have the highest value. So we're sorting those, and then we're getting all the rows, the last ones, which have the same value. Okay, so whatever that highest value is, we'll find all those rows and then pass all of those into the max function and return the maximum name. So in this instance, there's only ever one partition for each value. Those partition position values are unique. So we're only passing one value here. But if somehow, there was able to be two partitions with position 10, for example, it would apply this max function to those names. So whichever name is the greatest, according to the alphabetical rules. This situation doesn't matter. But what this allows us to do, find the name of the last partition. Now, thing to be aware of, some people might have a script to try and say, okay, we want to rename our interval partitions. We want to find the last partition, and because that's the most recent, right? And then give it the name of the current month or whatever it is. So be careful. Remember, interval partitioning will generate a new partition as soon as you insert a value which doesn't have an existing partition for. So usually this is something on something like insert date, and usually it'll kind of keep in sync with now. So we're inserting sys date as the inserted date, keep going. We've got December's partition, 1st of January comes around, we'll create a new partition, then that will become the new highest partition. Usually that's how things roll. From time to time, someone may, for whatever reason, decide to insert a row for a partition that's way in the future. So let's say I'm going to add a value for the 1st of January 2020. So I stick that value in, and then I realize I made a mistake and roll it back. Well, that partition still exists. Okay, so you need to be careful if you're trying to find the last partition with interval partitioning, because it's possible that someone's pre-created it without realizing, and when actually you want the value somewhere in between. So how can we find the partition for a particular row or a particular value? So today's the 13th of December. How do we find which partition those rows are in? Well, there's another little technique you can use. So how can we get the partition for a particular row? There's this handy little partition for syntax. So you've got your table name and you say partition for a particular value, and it will return you all the rows in that partition. So here we are getting December's partition. We can then join that to user objects on the data object ID to find the partition name, the sub-object name. So that extract those values out. So this is a neat little trick. You say, I've got a value, I want to find the corresponding partition for it. One thing to be aware of on this value that you pass in here must be a literal. You can't use a bind for it, unfortunately, which is a bit of a pain in some scenarios. So you might have to use dynamic SQL for this. Okay, questions, comments on that? Okay, all right then. How many people here are using interval partitioning? Can we see who's online? We use it, Charlie. Okay. Yep. Are these issues that you're encountering? Are these things that you find are an issue? Is this naming issue or finding a particular partition a problem for you, Charlie and Mark, or is this you completely irrelevant? You're thinking about it. Okay, so yeah, it hasn't been an issue. We have enough people to keep an eye on them. Okay, not yet. Yeah, definitely solves the oops, we forgot to create next year's partitions problem. Yeah, there's something that years ago encountered quite a bit. I joined a new company, and the job role that I took, he was in charge of sorting the partitions out. And of course, that job wasn't fully handed over for various reasons, and everything broke on the 1st of January. Lovely. Yeah. Yeah, I suspect this naming issue isn't a big deal for most people. It's in one of those nice to haves, but I can see it's useful in some circumstances. Okay, so let's move on. There's one last thing I wanted to cover on interval partitioning, and then we'll go back to your Pojan's question and come back to yours, Charlie, unless something else comes in. Okay, so that is one thing, is how do you drop the first partition? So as I said, one of the good reasons or big reasons for using date range partitions is some kind of archival strategy. You want a way to quickly and easily just get rid of whatever the oldest data is. And when you've done that partition by date, you can just drop that partition and it's gone. Quick and easy. However, there's a little problem with this when it comes to interval partitions. Why? Well, if we look in the data dictionary, we can see we've got the partition names, and we can see whether or not they are an interval partitioned column. There must be, or the first one must be a non-interval partitioned partition. So the first of these must say no when it comes to dropping the partition, which in the past was a bit of a problem. So if I wanted to get rid of P0, so everything before 2018 or whatever I set the start date to, and I tried to drop it, we get the lovely error 14758. So we couldn't get rid of it, okay? This is a bit of a problem if you wanted to use this as part of your archival strategy. You know, it's like, great, we saved ourselves the hassle of remembering to create these partitions, but now we can no longer get rid of them. All right, well, what do we do? Well, the good news is, I'll give you the quick short answer first. This is fixed in 12.2. So as of 12.2, you can now do this, and again, under the covers, we'll sort this out for you. So the next last partition becomes, we convert it to a non-interval one automatically. If you're not on 12.2, you're on 11.1 through to 12.1, well, what can you do? Well, there's a little trick. You can just change the interval for the partitioning. So you just set the interval to whatever it currently is, and what that does is it kind of harden or makes the partitions non-intervals. Don't ask me exactly why it does this in the background, but all you need to know is that it does. So you can see after having reset the interval to exactly what it was, they are now non-interval partition tables. So you can drop them off and do whatever you want. So handy little thing to be aware of. They say, if you're on 12.2, this is fixed. You don't need to worry about it at all. If you're on 11.1 to 12.1, then you can just do this set interval, the same interval you've already got, and it will sort this problem out for you if you need to drop those partitions. Okay, so that is all the stuff I had. So if you've got questions on that or other questions, please start putting them in the chat. In the meantime, I will go back up and start looking at some of the other things that we've come in. Okay, excuse me. So we had the question coming in about what is the recommended indexing strategy for table archival and temporal validity for both partitioned and non-partitioned table? For example, the HR employees table. Assuming the table is partitioned by hire date, say I want to create an index on department ID, what should I include in the column list? Okay, so the first answer to that is you should think about it as a non-partition table. Consider which index you want to create. So if you want to search on department ID, then you probably want an index on just department ID. Okay. The next thing you need to consider, if you have partitioned it on a column that is not the one you're indexing, is which other do you want a global index or a local index? So a global index is one which points to every single partition. A local index splits it up into effectively mini indexes for each partition. So a bit like we take the table and logically split it up into smaller tables, local indexes take the index and logically split it up into smaller indexes. Now, which is better, which is right? Again, it depends on what you're trying to do. So in the past, global indexes have the big advantage of that they point to, they go across the whole table. So something like department ID, when you're partitioning by employees hire date, well, you're going to have departments spread throughout all the partitions. So chances are you're going to have to hit a lot of them, possibly all of them. So by having one index structure, you can just read that as one thing. Whereas if you've got separate local indexes for each hire date, then you're going to have to read n separate indexes. So it's potentially more work. So from the search perspective, the global index is probably a better way to go. However, this created a problem when it came to partition maintenance, particularly if you dropped a partition. So let's say we removed all our oldest partition. We need to archive off all the old employees. You probably want to partition maybe by fired date, or not fired, or last day of work date rather than hired date. So you can say anyone who worked at the company more than 5 years ago, we will wipe their records because we don't want to keep that information around for whatever reason. So if we do that, you drop the old partition. Well, now your global index has all these entries which point to rows which don't exist. So we had to do a lot of work to kind of sort that out, which was quite expensive. I forget whether it's 12.1 or 12.2, we have asynchronous global index maintenance. So now you can drop off that old partition and kind of in the background, it'll sort that out for you. So in terms of recommended indexing strategy, again, just think about which rows you're searching for. Ideally, your index, all the columns in your index will be in your query, probably in the where clause, and figure out which gives the most efficient, and then do some assessment of local versus global indexes and see how that pans out. So if you've got follow-up questions, let us know. And see his follow-up come from Judith. Okay, so what happens if the existing partitions do not cover the full date range, aka months are missing in the middle, and you reset the interval? So that's a good question, Judith. So you've got, let's say we've got monthly partitions up to today. So we've got all monthly partitions from now to the 2018, end of 2018. Someone inserts a row for the end of 2019, so we got a partition in between. So when you stick with interval partitioning, although if you insert a row for the 2019, so December 2019, for example, it creates that partition with the upper bound for it. It will still create all the partitions in between as we add the new value. So come the 1st of January, you're not going to have everything go in that one giant 2019 partition, and the interval partitioning will sort that out for you. It'll create a separate one for January, and then you get from 1st of February to the end of 2019. So that will be fine. However, when it comes to resetting the interval, that is a good question, and I must admit, I don't know the answer. So why don't we do a test? Let's do a little test. So let me pull the code out of the slides a second. So if I go back up, and where is my create table? Here it is. Let's see what happens. So, okay. I don't know what it is about PowerPoint, but it sticks these weird characters in your code when you copy paste. If anyone knows how to fix that, please let me know, because it drives me mad, and I'm never sure how to solve it. So let's put that in. Let's stick some values in for these silly characters. What are these? So let's put those in, and we will query that. See what happens. So in they go, in they go. So let's just create that, and we will have, so we got our partitions there. So let's now insert a row for the end of 2019. So let's say 2019, 1231. There we go. Commit that. So now we can see we've got this extra partition at the end going up to 2020. I'm not sharing my screen. Okay, let me just share the screen, sorry. Sorry about that. Something jumping out of PowerPoint. Okay, so have you got my screen now? Yep, okay, sorry about that, folks. Okay, so let's just run this again. So these are the stuff I've just taken out the slides. Let's drop the table. We're gonna have interval partitioned, and we'll create it. So we'll see, we've now got 4 partitions up to, May this year, and then we've got 1 partition dangling out on its own end of next year. So just to show that it will split that in between, if I put something in for this month, we'll find we get another partition. Oh, there it is. That's that one. Yes, so that's that one. So it is splitting these up. So we are splitting these partitions out correctly. What happens if we do the set interval? Alter table T set interval month. Okay, so let's look and see what's happened. So here okay, so it's converted them to non-interval partitions, but actually maybe it has that. Let's put that in. Yeah, there aren't 31 days in November. Helps if I get the month right. And let's put something in for October as well. What's happening now? We will find that, okay, it's still creating, nope, no, it hasn't created those new partitions. So something to be aware of, yes. Okay, so this is, I'm running on 12.2 here. I doubt this has changed in 18C. I didn't remember seeing anything about that. So something to be aware of there. Yes, so it's kind of losing the interval. So if you have got these sparsely populated dates with an interval, and you magically set the interval, then you've fixed the boundaries for all your intermediate partitions. So you probably have to go through a process and merge those, unfortunately. How do I have a partition that contains just partition key is null? Sorry, I'm not sure what you're asking there when you say when you have partition key is null. So you mean insert something, add something like null, like that? Yep. Well, if we try and put it in, give you an error because it's non-existent. It doesn't map, null doesn't map to a particular value. We don't know where to stick it. So you're going to get an exception. So even though, notice it's not a not null column, okay? So the only workaround is create some high date for that. So what happens if we have a max value? If I ditch that and I can create a p max here. Max value. Helps if I can spell. There we go. P max. So this is what we would have done in the past before interval partitioning to save us from partitions missing. And we try and insert that now. Yeah, it goes in because it matches to the, theoretically it should create a max value partition and put the null there. Max value and interval together. As far as I know, they are mutually exclusive options because it doesn't make any sense to have a max value. Yeah, you can't do it. Max value, so you can't mix and match those together. Okay, which kind of makes sense. You shouldn't be able to do this. While we're kind of on this topic, I think it's worth mentioning. So these interval partitions are for range partition tables. So these where you've got values that increment in a date. You might also want to do this for list partitions. So here's where you've got values going into a specific list. So if we do interval by list, and these have a specific value. So values, so 1 goes in this partition and 2 goes in that partition. I haven't named them very well. So again, this would have the problem where, well, what happens if I try and insert the value 3? All right, you're getting an exception. That's not great. Oh, no, helps if I insert enough values. There we go. Got 2 columns. Insert partition does not match to any partition key. 12.2, we implemented automatic list partitioning. So you could, it would generate these on the fly. So we can do something like automatic, create the table. So now we can stick it in and it's created the partition for us. So nice little handy feature if you've used list partitions. Okay, any other questions we got about partitioning or if not, I will go back up to Charlie's question that came in at the start. All right, so Charlie, I will come and let's look at your question and we can come back to any others on partitioning. People are busy typing at the moment. Okay, so question on union or. Can you talk about and maybe describe an example of how using a bunch of union all statements strung together can lead to excessive memory resource consumption? I had a developer try and run a statement that consisted of 26,000 union alls concatenated together. So that's, you really mean 26,000 tables, Charlie? It spent 57 minutes in parse phase and I'm having a hard time to explaining to her why this is a bad idea. Okay, so were they all different tables? 26,000 different tables? Or was that, what exactly was the nature of the things that were being unioned together? Okay, why are you try and give us a bit more detail if you can. I don't think you're gonna find anything specific in the docs which is gonna say, that's crazy. I mean, clearly that is crazy, but but it's worth remembering when, every time you submit a SQL statement to the database, the optimizer has to try and figure out how to run it, has to figure out the execution plan. And the more possibilities there are, the longer it's going to take to do that. So, if you've got 10 tables, for the sake of take a 10 table join, so there's n factorial orders you can sort those tables. So you could go like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or 10 down to 1, or any other combination. So that's already a huge number. And then there's various different joins. So there's 3 different joins, nested loop, merge join, hash join. So you can multiply that up by 3. So there's a huge number of possibilities, and so the search space is massive. And at certain points and certain complexities of SQL queries, the optimizer is just going to take a long time trying to figure out all the various options, all the ways it can possibly combine all the tables. And certainly 26,000 union all branches is 26,000 select value from dual. Yeah, okay, so it's all select from dual. Because the developers cannot insert values into production, so as they do that so as workaround to search for specific values. Right. So so is this to avoid like an in list type query? Is that what you're? Because yes, I mean this is yes to avoid an in list. Okay. I mean, an in list with 26,000 values already sounds rather weird, right? I mean, where do these values actually come from? Yeah, hideous. I mean, what exactly is sending these 26,000 values? And how do they get generated? Okay. You know what? I'm just gonna do something. Let me pull up the query itself. Where you can, yeah, if you, well, don't give us the full query, and we'll but I'm just trying to get some idea. So if this is to avoid, because it's avoid the 1,000 value list for an in list. Well, what is actually how do these come from the application to the database? Because surely you're not got a person there clicking. There's no way someone's clicking 26,000 values. So where do they come from? Where do these all come from? This is a one-off query they run when troubleshooting an issue in production. Right. Okay. Okay. And where do they get their values from? And they get a list of possible records that may have trouble. Okay, so they've got the support ticket or something like that, which says these are the things which are suspicious. Check them out, figure out what's going on. Right. Okay. I mean, this is pretty crazy. I mean, so one question is, can you do something? Yeah, an individual bunch of. Can you do something like create a temporary table for them to stick the values in and run the query against that, rather than just manually typing them all out? Is there any way to do something along those lines? We floated that exact idea, but management is very low to developers the ability to insert anything to production, even into a temp table. Okay. Is there any particular reason for that? I mean, at this point, you're kind of talking about things that basically don't work, because I mean, inspecting 26,000 values is just not going to work very well. Speaking of that, the inline function doesn't seem to support array output. If that is the case, we can send one CSV string and have to split into an array. Okay, so I'm not sure what you're saying about the inline function there, Pojin, but yeah, one thing you could do is pass them as CSV list and do some parsing to split them out into values. So rather than 26,000 union alls, you could have several or a few concatenated CSV lists, which you then split out. That's yeah, exactly, Oren. Yeah, something that splits out, it takes a CSV or a number list as well. That's a possibility. Yeah. Awesome, having them query in a standby database. Okay. Given we can't create the function type, we can also use an inline function. You're talking about the with clause there, Pojin. I'm not sure what you mean by inline function. Yes. Okay. Well, you don't even need to create a function to do a CSV to column splitter. There's various ones available you can look up. And create a temporary table in another database and exit through a database link. Yep. So there's lots of interesting, good. Well, you're more interested in what I said about n factorial permutations of the query, right? Yes. Basically, the optimizer has to try and quickly come up with the best plan. But as you have more and more tables and more options, the ability to come up with the best plan is limited. You know, it's one of these hard computer science problems. As far as I know, there is no general case solution which is guaranteed to find you the best plan in the shortest time, you know, once you get beyond a certain complexity. So, and it also has to do things like parse all the text, validate that, okay, select from Joule, fairly straightforward, but it still needs to do various syntactics, semantic checks, validate you've got access to the tables, that they all work and things like that. It's just a whole bucket load of work that it's doing, trying to figure out the statement. And if you have thousands of tables in a SQL statement, it's just going to take a long time to parse it. I mean, if you're trying to like explain this to management, ask them, say, right, you've got 26,000 things, figure out the best way to optimize them, whether you've got access to do it, whether it's syntactically correct, which order to process them all. Ask them, how would they do it? And they probably go, bleh, you know, 2 queries, 2 meg of text, yeah. So, you know, it's just fundamentally, I think at some point, you're going to hit the limits of what is feasibly possible to do in a short period of time. And 26,000 branches definitely hits that limit, if you ask me. So, suggestion coming in from Tadeo, you can also create the table in the production data and only use it to populate the values when you're debugging the issue. Yeah, I mean, that's what I was thinking, hoping they would go with, like a global temporary table, because then the values only exist in your session. Once you disconnect, it's gone. So you don't have to worry about clobbering other sessions and so on. Udith, maybe a with clause with a materialize hint. That might help. I still think that might help a bit. I still think just the overhead of processing that many tables is just gonna, yeah, it's always gonna be a struggle. Dev leadership likes the temp table, ops leadership does not. Any particular reason they don't like it? Other than I don't like my developers doing stuff on production. I think like a good reason. Yes. Yeah, this might avoid too many. Yeah, that might help. I say the materials might help, but I think it's just pendulum is swinging back from developers having too much access in production. Okay, yeah, I've been there. Developers were able to do everything, were they? And now someone's gone, hang on, that's probably not a great idea. Is that the background? '18C private temp table option is attractive once we upgrade. Yeah, so that's, yeah, let me just do that, share that quickly. So again, this is something, I've got my table. So, so this is something in 18C, C1 int. So hopefully I've got there we go. I've got that right. So now this only exists in this session. No one else can see this table. And so I can insert into it and put what values I like in there. Oop, I don't know, helps if I get the table name right, doesn't it? Copy that. So I'll stick values in there and then I'll query it. So that's all fine. But as soon as I commit, what happens? Well, the table's gone, right? Okay. So it only exists in your session, but by default, it has this on commit clause, on commit, preserve, or drop. By default, it's dropped. We could set it to preserve, preserve definition. I hope I've spelled that right. There we go. So now, even though I've committed, it still persists. Okay. But now, as soon as I disconnect, so let's just disconnect from there, and then I shall reconnect. We'll find that the table has just gone completely, so it no longer exists. So that's something, if you get to 18C, it's worth doing, and then each individual developer can have completely different private temporary tables. So if I open an unshared worksheet, so I've got 2 sessions running on my database now. So let's take a second or so to go. So I've got this one, which has got 1 column in it, and this is the same database. I can create another one which has 2 columns in it. There we go. So 2 sessions at the same time can have different private temporary tables. So maybe this is a bit more palatable to your management and so on. So the table itself only exists for the duration of the session. Yes, nobody else can see this, not even the data dictionary. So if I try and look for it in user tables, let's see, what do we get? Nothing. Okay, nobody else can see this. If you've got developers who've come from a SQL Server background, they'll probably be quite familiar with this concept. So, it's a temporary. The definition only exists in memory. It's not persisted to the data dictionary. And it's DDL, but it's not real DDL. You can actually do things like rollback across it. So what grants are required to create one? I believe you'd need create table, but I have to check that one. So that's a good question, because it is still yeah, that might be the deal breaker. I'm not surprised. Well, we can try this. Create, let me just try session to you. Let me just make a new user. Make a new user. Let's see, identified by test you, test you, and let's try and create it. Let's see what actually happens here. Yep. Helps if I terminate it, doesn't it? There we go. So let's create the user, we'll connect, and what's going to happen now? Yeah, insufficient privileges. So if I do create table and connect, have to wrap it in a function. Yeah. Yeah, you'd have to have some kind of PL SQL procedure which ran it for you. Obviously, then you're going to be very careful about what you're allowing people to pass, because if you're allowing them to create tables, in theory, they could create anything. So you have to have some validation. I guess maybe you could pass the column list and table name or something, but we already use that for restricted functions. Okay. Do note, I've got this lovely little $or $PTT prefix. I haven't done that because I like prefixing my table names. I really don't. You have to specify this, and it has to match whatever this private temp table prefix value is set to. Okay. If you try and just create table T, then it's not going to work. So bear that in mind. Okay. Anyone got any other suggestions, questions, comments for Charlie on how we can solve this? There is a need for a separate create temporary table privilege. That, or create private temporary table, potentially, yes. That could be handy. I could see that people would want this, particularly in read-only environments, or read mostly environments, reporting where they need to just scrape. Yeah, there's workarounds for that. Okay. So that's something that can help you. In the meantime, as other people have suggested, you can do things like select V1, V2, V3. So rather than having 26,000 tables union together, you can quite a few of them as a CSV, and then do CSV rows to column splitting to actually generate the in list. So that avoids you having to access dual some bazillion number of times. Okay, so that's something else you could look at right now as a way around this. Any other? Yeah, no worries. How do you split it? So basically, you join it. There's a few techniques for doing this. Just to look up CSV to rows. I forget them off the top of my head, but you can do something like join it to a table which has however many rows there are, so how many comments. So then we do join that to the string and just do substring, in-string, or regular expression splitting out to get the values. There's a few techniques around. If you Google CSV to columns, you'll find one. All right. That's an interesting problem there, Charlie. Thanks. We're getting close to the hour. So has anyone got any final questions or comments they'd like to add before we wrap up? No? Okay then. Well, just want to thank you all for joining me in that case. We're most of the way through December. It's approaching the end of the year. I hope you have a great holiday, festive, whatever you celebrate at this time of year season, and you keep safe and have a great time with whoever's close with you. It's great to see you all. Thank you for joining me. I'm Chris Saxon. I hope to see you again in the new year. Goodbye.